lesson is about double angles. Now you recognize a double angle by looking at 2 times something and 2 times something. Again, we have certain patterns. Sine of a double angle is 2 sine A cos A, and cos of a double angle is cos squared A minus sine squared A. Or you can write it as 2 cos squared A minus 1, or 1 minus 2 sine squared A. So all three these have a double angle of cos 2A. These formulas are in your notes. Can I carry on? Now let's look at some examples. Our first example is sine 4A. The first thing that you need to do is to write this 4A as a double angle. 2 times what? So it will be sine 2 times what gives you 4A? 2A. Now we write this 2 in the front, and then we do the pattern sine 2A cos 2A, and there's your answer. The 2 of the double angle goes in front, and this becomes your angle of your pattern. Sine 2A cos 2A. Let's look at another one, sine 50 degrees. We have to write the 50 degrees as a double angle. So it's sine 2 times what? 25 degrees. This 2 of the double goes in front, and then we have our pattern sine 25 cos 25. Any questions on those two? Okay, number 3. We have to write sine A as a double angle. So it's sine 2 times what gives you A? A half A. So it will be A over 2. Very good. The 2 of the double goes in front, and then we do our pattern. Sine of A cos of A. I like asking this question in tests. Alright, now we move on to cos. Cos 6A. First, I have to write it as a double angle. 2 times what gives you 6A? 3A. Now for cos, you have three options. Let's write all three so that we can learn the patterns. The first one is cos squared of the double angle 3a minus sine squared 3a. Or you can write it as 2 cos squared 3a minus 1. Or you can write it as 1 minus 2 sine squared 3a. So all three of these are the same concept. It depends on what you want to do with your sum, whether you only want sines or only want coses or want both of them. Let's look at number 5, cos 80 degrees. First step is to write it as a double angle. Cos 2 times 40 degrees. Again, we have three options. It can be cos squared 40 degrees minus sine squared 40 degrees, or 2 cos squared 40 degrees minus 1, or 1 minus 2 sine squared 40 degrees.
You mark either one correct. You mark either one correct.
Yes. Alright, cos A. First write it as a double angle. Cos 2 times what gives you A? Judah? What goes there? A over 2, yes, very good. So we use our cos pattern. Cos squared A over 2 minus sine squared A over 2, or 2 cos squared A over 2 minus 1, or 1 minus 2 sine squared A over 2. Any questions so far? Everybody with me? Can I carry on? Number 7. Now I give you the second part of the equation and you need to write the double angle. If you have a pattern 2 sine cos, what will the double angle be? Sine. Sine 2, so that 2 goes in there. And what will be my angle? 3 theta. Now I can multiply the 2 with the 3 theta and you get sine 6 theta. Number 8. Again, I give you the second part of the equation and you have to write the double angle. 2 sine cos will be a sine double angle. What goes in the bracket? A over 2. 2 times A over 2 gives you sine A. Hmm? That's the reverse, yes. Okay, let's look at number 9. Now I give you 4 sin x cos x. I have to have a 2 sin x cos x. So I split the 4 into 2 times 2 sin x cos x, and this will give me the double angle. So it will be 2 sine 2x. This 2 is the double 2. The next one, cos squared minus sine squared will be cos, the reverse of cos. So it's cos 2 of what angle? 2 theta. And now you get cos 4 theta. Number 9. Okay, for sine, I needed 2 in front. So I split the 4 into 2 times 2. So this part is my double angles, second part of the equation. That 2 is my double 2, so the x is my x. Number 11. 1 minus 2 sine squared 2 theta. This looks a lot like a cos of a double angle. What is my double angle? 2 theta. 2 times 2 theta gives you cos 4 theta. Now I have sine squared minus cos squared. Which one is that? It's cos, but it's sort of swapped. Because with cos, the cos must stand first and then minus sine. Here we have sine minus cos. So let's first swap the two. Minus cos squared theta plus sine squared theta. And then we take out a minus 1. Cos squared theta minus sine squared theta. And now we have our double angle for cos. So it will be minus cos 2 theta. Everybody with me? Okay. Why is it not? Okay, because you take this theta, you take the A and only write the A. Okay. Number 13. 2 sine cos is a double angle for sine. So it's sine 2 of 15 degrees. 2 times 15 degrees gives me sine 30 degrees. If you have to do it without a calculator, you need to draw your special triangles. 30 degrees is here at the top. Sine is opposite over hypotenuse, so it will be a half. Number 14. One minus 2 cos squared is definitely cos, but it's the wrong way around. So let's write it cos first. So it's minus 2 cos squared 22.5 degrees plus 1. The signs is not correct, so we need to take out the minus 1. And then we have 2 cos squared 22.5 degrees minus 1. This is my double angle for cos. Minus cos 2 times 22.5 degrees. And then we have minus cos 45 degrees. 45 degrees is a special triangle. Cos is adjacent over hypotenuse, so it's 1 over square root 2. But I'm not allowed to have a third as a denominator, so I multiply with square root 2 over square root 2, and then you get minus square root 2 over 2. Our last example. This will be a typical question in a test because it also tests bracket squares, algebra. If you have a bracket square, you first square the first term, so it will be cos squared 15 degrees. Now you multiply these two terms and with 2, so it's plus 2 sine 15 degrees cos 15 degrees, and then you square the last term, so it will be plus sine squared 15 degrees. Now if you look at last year's identity, sine squared plus cos squared is 1. So in my equation there, I have a sine squared plus cos squared. So these two terms equals 1 plus, and this one remains 2 sine 15 degrees cos 15 degrees. Here I have a double angle for sine. So it will be sine 2 of 15 degrees. That is 1 plus sine 30 degrees. 30 degrees. Sine is opposite over hypotenuse, so it's half. 1 plus a half gives you 1.5, or 3 over 2. Any questions? We did a lot of examples now. Do you get the flow of these patterns? Double